Merry Christmas, my dear viewers, and welcome back to the Rocket Tub. My name is Philip, and today we are going to talk about one of the most important spaceflight missions in the entirety of history and discover the true potential of the James Webb Space Telescope. Finally, after almost 25 years of development, building and testing, we are just a few hours away from the launch of the James Webb Space Telescope. On the 24th of December 2021, the JWST is set to lift off on board an Ariane 5 during the VA256 mission. From the launch complex in French Guiana to space, the Space Telescope is being taken to its halo orbit around the L2 Lagrange point of the Earth-Sun system. Once there, Webb will start its mission and take the first images of distant objects. At least, that's the plan. The telescope itself is a wonder of modern engineering. I mean, the $10 billion of budget must have gone somewhere. The telescope possesses a main mirror with a total diameter of 6.5 meters, which is made up of 18 hexagonal, gold-plated beryllium segments. These smaller segments are arranged in two rings with 12 and 6 segments each and a hole in the middle for the sensors and instruments. Webb's equipment includes multiple infrared and near-infrared cameras, sensors, and spectrographs, which are able to see way further than the Hubble and other space telescopes, as well as an optical guidance camera. To protect those instruments, Webb's mirror will always face away from the sun and hide behind the Sunshield. The Sunshield is positioned between the mirror and the sun and keeps the temperature of the instruments below 50 degrees Kelvin. The success of the mission is depending on many factors: the launch vehicle, the in-space propulsion, and most importantly, the unfolding mechanism. The James Webb Space Telescope has to be folded multiple times since it is far too large for the Ariane 5's 4.5 meter fairing. Once in space, the telescope has to unfold autonomously, and even a little mistake can threaten the entire mission due to us not being able to intervene from 1.5 million kilometers away. So, we have spent almost $10 billion of taxes on a set of infrared cameras and which are mounted on a foldable spacecraft that might not work out after all. That certainly doesn't speak for the James Webb in any way, right? Well, let's take a closer look at the scientific value the Webb may be able to deliver. Due to the James Webb primarily being an infrared telescope, we can't expect too many classic pictures from it. But the infrared instruments enable the Webb to look further into the universe than anything before it. The limits of Hubble and other telescopes defined our knowledge about all the universe for decades. But the Webb offers a new opportunity to see objects further away than anything we know today, and therefore look further into the past of the world around us and maybe discover some new hints for new spectacular theories. Since the James Webb Space Telescope can see light we've never been able to analyze before, it should be outfitted with instruments strong enough for catching the light of really dim objects. Maybe the most interesting of those objects is the speculated ninth planet of our solar system. Gravitational interferences and the orbit of some planetoids in the Kuiper Belt indicated its existence, but we haven't spotted anything planet-like in the suspected areas until today. Maybe because it is just too dark to be seen. But should it really exist, the Webb's infrared instruments may be able to catch a little bit of reflected light from Planet 9 and finally prove either its existence or its absence. Additionally, infrared light is able to pass through clouds of smoke and even atmospheres, meaning the Webb can see objects normally hidden behind many layers of cosmic dust and even behind the galactic plane. Therefore, the James Webb Space Telescope can see objects we haven't seen in a similar quality before and enables us to research unknown areas of the visible universe. Additionally, the James Webb is able to register light passing through the atmosphere of exoplanets during transit. When a planet transits its star, it blocks some light and the star dims down slightly. This mechanism has led us to the discovery of thousands of exoplanets. But for the first time, we will have the ability to actually measure the spectrum of the light that passes through the atmosphere of such planets from light years away. By filtering out any light that didn't pass through the atmosphere, the scientists will be able to identify the gases in the atmosphere of the exoplanet and their specific percentages. And along with the analysis of planetary atmospheres, the James Webb Space Telescope may become the instrument to first discover life on a foreign world. In fact, we could already have found an inhabited planet, but we just wouldn't know that there are aliens there. By identifying the individual gases in an exoplanet's atmosphere, we could search for certain biomarkers to prove the existence of life on that specific planet. The most obvious of these biomarkers is probably oxygen. Normally, elemental oxygen is quite rare in planetary atmospheres and often bound in carbon or nitrogen compounds. But the atmosphere of our home planet has a total of 21% of oxygen in it, which is a result of photosynthesis. Should plants or other organisms conducting photosynthesis exist on a foreign world, the James Webb Space Telescope would be able to spot the oxygen produced by these organisms in the atmosphere of that specific planet. The scientific discoveries and the not even that small chance of finding life that the James Webb Space Telescope offers us is just phenomenal. After 3 decades, NASA needs a new flagship mission to satisfy hungry scientists from all over the world. But all of it has a fairly high price. Once operational, the project will have cost almost 10 billion US dollars. That's a lot, but remember, 10 billion is nothing compared to the yearly military budget or even the SLS program. Critics of the James Webb Space Telescope often point out these costs as a counter-argument, but they seem to forget the pure scientific value of the web. And that's already it for this video. Leave a comment on what you think about the topic down below, and if you enjoyed the video, which I really hope you did, why don't you smash the like button and subscribe to the Rocket Tab. It would really mean a lot to me. We see ourselves in the next video, and until then, I'm out. Cheers!